Hi, I'm Mick Moylan from the School of Chemistry at University of Melbourne.
Hi, I'm Daniel Pike. I teach physics at the University of Melbourne.
And I'm Lisa Godinho. I'm from the School of Biosciences at the University of Melbourne.
We're going to be talking about some Prac classes that we're running and a Prac program that we've been running this year in the Bachelor of Science Extended program. We're giving this talk about something that we decided to do under a lot of stress at the start of the lockdown. The outcomes have turned out to be, we think, much better than we anticipated, and in quite a few cases, better than doing face-to-face pracs. I'd like to acknowledge that we're on Wurundjeri country, and I'd like to pay my respects to Wurundjeri elders past, present and emerging, and I'd like to pay my respects to traditional owners of the lands that you are on as well. We've been posting Prac kits to our students this semester, and we did that for two main reasons. We did that because we felt like we were not able to satisfy our learning outcomes with students doing recorded or virtual pracs. We also did that to keep our students engaged, to keep them doing science, to keep them actively practicing their science and developing hands-on practical skills. So these three things were the most important design principles in our development of these practical kits. Safety, of course, the idea that one of our students would have an awful accident and we wouldn't be able to do anything about it. So for chemistry pracs, we always worked in water. Nothing flammable, nothing dangerous. We wanted to hit our learning outcomes in the best way that we could, and we wanted to keep our students as engaged as we could. We're teaching into a program that is for Indigenous students. It's a 4-year Bachelor of Science degree, and we're talking about these 3 transition subjects which are multidisciplinary. They're taught with a core of chemistry, physics and biology, and they have contributions from mechanical engineering, geography and food.
I've been teaching the biosciences component of these multidisciplinary subjects, and these images here just give you a bit of a sense of the breadth of biology that they were doing in their own homes. We had a lot of fun packing up these kits and sending them out to the students. It was like packing Christmas gifts, and the students, before we went into serious lockdown in Melbourne, I was able to hand deliver some of these packages to some of the students. Others had to be posted, and the look in their eyes when I handed over the package was like they were getting the best Christmas gift ever. So they were really excited about it. We were really excited about it, and there was lots of really great activities that we were able to do with the students as part of these activities. So the Prac that I want to talk to you about today is one where students were setting up equipment in order to measure the effectiveness of yeast using particular sugars. So they were sent as part of their kit, they were given a test tube and some rubber tubing, and they were given some different types of sugars, and they were trying to work out which of the sugars was best and used fastest by the yeast in terms of their fermentation process. Now, this output of this fermentation process is carbon dioxide, and so the students needed to set up their kit. They just got the test tube and the rubber tubing. They needed to set it up in such a way that they could measure the output using the displacement of coloured fluid. So they have coloured fluid in the base of this tube here, and they needed to make sure when they set up their own kits, and you can see all the variations over here on the Zoom screen, they found all sorts of interesting ways, including taping it to their own wall. I hope it didn't rip the paint off when they removed it. They used cardboard boxes. Some of them had cork boards, and they had to really consider what the equipment was trying to do in terms of measuring CO2 output and make sure that they set theirs up in such a way that they could measure that. And so they had to really think about the setup beforehand and do a lot of preparation coming into the Prac, which was something that they don't normally get to do in the lab, and it was a really nice experience for the students to take ownership of the Prac in this way and have to set it up themselves in their own home.
And in the physics question of how you can do a physics lab at home, we also posed the idea of most of the time you've got big pieces of equipment, you've got accelerators, you've got whatever else, but we needed to nail down something that we could test some physics ideas in a home environment. And that ultimately came down to, in the part of the course that I was teaching, which is generally foundational physics, so it's all the kinematics and thermal physics and basic ideas, we do some thermal labs. And the lab here that we was testing was about Newton's law of cooling, or the idea of a relationship between temperature changing relative to ambient temperature. So the idea was put to the students to how they could do this, and the basic idea that came out of it is we're going to use a thermometer to just test how colour changes the absorption or the emission from things, and using basic household equipment. So again, like everyone else has done in these labs, we decided to do this with 2 cans of soft drink and a thermometer. The students, when doing these labs, were testing the temperature change, and you'll see here in the photos from the bottom left to the bottom right, all the variations of various ways they could export this. So the students, one of the good things about this lab is the students could unpack really what was going on a lot better. They could understand, often in lab equipment, there's a black box environment where you've got something like, in physics, a Pasco cart or some sort of bio equipment that runs through Bluetooth, and you don't really see what's going on. But here, because of the fact that they had to do it themselves, they could actually get a feeling of what was really happening a lot more, and so they could understand the concepts better. So you'll see students actually exploring that. With the bottom left shows a student who sandblasted the cans so they could get a different effect, and then put pitch black on the other one to really make that color difference. Others were using different kinds of lamps, like heat lamps and spotlights in the second one. And then you even find people in that had different kinds of methods. The far right 2 photos show that the student was initially using an LED globe, but only realized later how that would not provide kind of ambient temperature change. And so they moved on to using an incandescent. And that understanding was reflected in the data that came back. A lot of these times we see students in normal labs not understanding what even to plot coming out of these labs. But these students not only understood what to plot coming in, of having a deeper thought process involved, but they had a lot of the elements you tend to hope that they'd add, like error bars and showing those relative values in a clearer way. Now, not everything always worked. Some students still didn't get great data. You'll see that on the right-hand side there, that perhaps also they didn't work out quite the right kind of fits in the first instance. But their reports would reflect that. They would have, during that process in the analysis and the understanding, they sort of could have more considered approaches to things, and so that could be explained through in the reports that we got back from them.
In the chemistry aspects of our subjects, these are the things that we did, and we were looking particularly at things that the students could do, things that the students could take realistic measurements in, and situations where students wouldn't have the same learning outcomes if they didn't get their own gear, particularly with volumetric glass, where you can't learn how to use that without holding it in your hand. One particular prac that worked very well was this one here, where students extracted the pigment from some leaves, diluted that in water. We posted little cuvettes, and then they made their own spectroscopes. And I've got one just here with a little bit of DVD, a pre-set template, which is available online, and some black paper that we posted to them. And the students glued stuck the outlet of their spectroscope to their mobile phone cameras and got really good spectra. Then they they used a website to analyse their photos to get intensity data for each pixel. So they're looking at the difference in light intensity across the visible spectrum. They subtracted a blank, took a blank and then subtracted that data from their samples, that they'd prepared from the leaves, and got some data. Now, the data wasn't incredible, and it ranged from being okay to terrible. But the thing that I think was really good about the learning exercise of this prac was that students kept doing it. they weren't constrained by the time period of the Prac. They learnt how to do the experimental work during our 2-hour class, but then they continued to take measurements and continued to submit data to that analysing website, which is how this data was collected, for the week after doing that lab activity. And they actually did more submissions outside of the Prac time than inside of the Prac time. And I think that's very important for first year learning, to give students, to remove some of that time pressure and to give students some ownership and agency in their practical work. These were some outcomes that were far better than we had anticipated, where students used the class time to develop their method, but then after class, they went on to refine their method. And in a way, some of this is like the olden days of science, where people built their own apparatus, they developed a method, they tested it, collected some results, had to analyse their own results, and then think about the meaningfulness of those results and maybe repeat their data collection to see if they could collect something better. So we've been thinking about how we might do this for some of our bigger subjects. We only have 10 students. We all teach into much bigger subjects, and we've been thinking about how you might go on and doing that. So here are some of our thoughts about the costings. But I think working in bigger subjects, obviously you can't do this for every Prac, but there are ways in the cost-cutting world to make this kind of learning cost less money, but also allow more learning opportunities and a greater depth in learning for the students. Ways to possibly do this would be requiring students to pick up their own gear, or even in this case here, put things in envelopes. The only thing that's difficult to get out of this is the little bit of DVD that makes the diffraction grading. So that completes our presentation. I'd like to thank you for listening. I'd like to thank all of our students for their patience and their understanding as we tried out something new this semester. I'd like to thank our colleague Dave Collis in Maths for thoughtful contributions to our work, and we look forward to answering your questions.